Hello everyone, welcome back. In this video I'm going to show you how to model stair in Revit. Before going into Revit, let's just go over the part staircase, see their name, and then it will be useful when we go to Revit. Without knowing those names, which one means what, you will not be able to model staircase in Revit. When we're talking about staircase, we have the steps. Okay, basically this is a step, and the place that we call landing. Now sometimes you don't have landing, it's just one straight line, it's just the steps. Now this part here, the step part, they call the run. This is run, and this will be landing here. So run consists of multi-steps. Now it has a width, they call stair width or run width, similar. Minimum, they say that it's 90 centimeter, it goes for 100 centimeter, 1 meter, 1.5, according to the stair. Then when you talk about a step, it has a height. The height of it, we call it riser, and this part here, which is the place we put our feet, we call it thread. So thread width and riser height, two information that we needed when we design a staircase. Now how many steps we need, it's basically depending on the height of the floor. Well, what else do we have it? Now run, it also has a thickness. There is a thickness here, we have it. For the landing as well, we have the thickness, we have the dimension of the landing, which is the width of the landing, maybe even goes in this way for the second part of the stair to go up, if it's like this, if you have landing. Now there are some other informations, not just, we have also, now this is not for concrete, but this one also appears in Revit. Nosing, basically if you have something like this coming out, it can be done with concrete. The concrete will be something like this. It can be made like this. This we call this one nosing. So talk about this one as well. Well, this is for wooden or steel. You have different name. Stringer with this spide, we have it here. There's other things that from the wooden and steels, I will not go into detail of them. Now sure, we know the distance and the height of this one. We'll start from where. Now when we calculating the number of steps, imagine this is where you start and this is where it ends. So sometimes it will be linked to the slab. The last step of it can be slab, especially if it's concrete. It will be managed in this way. This part will be concrete, so the slab will come and link to the stair will come and link to the slab. Now let's go to Revit. Now I'm going to show you another idea of creating an opening. Sometimes people will create opening when they do the staircase, the elevation, then they will create the opening. Now, we want to do this staircase. The staircase will start with the top of the foundation, which not exactly top of the foundation, because we know according to the plan we have it, the stair, we have it start with at 50 centimeter above. So we will manage this one. So the stair starts somewhere here, as you can see from this section. The stair start 50 centimeter above the foundation level, the top of the foundation. Since we know top of the foundation, it's a 0, so we have 50 centimeter above the top of foundation. But since I don't have this level, within the Revit, so I will choose top of the foundation. We'll give an offset 50 centimeters to start from here. Then it will end up, we know that it will finish at the top of the first floor. So those will be our constraints here. Well, we'll go to the top of the foundation first. Now, where do we exactly draw this one? We'll talk about it. We'll talk about it. We have some problems. Oh, we can manage it. It's not a big deal. We can manage it while drawing it. Well, in a structural tab, you cannot see staircase within the commands here. Well, Revit considers stair as an architectural element, so it will be under architectural tab. So we'll go to architectural tab. In the stair, you have two types: stair by component or stair by sketch. Sketch is completely, you will draw the everything by yourself. So you'll draw it and Revit will convert it to stair. It will give information. The other one by component, component we already know. We have run, we have landing, so riser, nose, thread, everything we will give it to Revit, and according to that one we will draw it. It's easier by component rather than the sketch. But if you don't have the case, let's go to component, we'll explain the sketch, will be easier. Now, if I go into stair, as usual, we know that three things going to change. We have at the top, we have here some options and the properties here. Now, when we mean by components here, look at the components we have it. We have run, which is the place, and landing we have it, plus support. Support will be for the beams, if you have beams, for the staircase. Well, look at the type of stairs we have it here: straight, complete circle, a curve you have it, L shape, U shape, different components you have it there. But if the stair that you're going to model, it's not within those components, in the beginning you will go by sketch. You will do the sketching by yourself. As it's shown, let's say you have a stair, it's like this, for example. You can do it still with here, but you might prefer to go with the sketching, or you may have something like this. Different type of stairs according to the location. Who knows how the architectural design is? So if you cannot find it within here, you'll go for the sketching. Sketching is complete drawing. You will draw it, and Revit will convert it to stair for you. Now I'm going to go into advanced level for stair, which is following the components here. Now, a lot of information here you have to take care of. Stair is very complicated. So the first thing we'll go first from the family here, we'll choose the type of stair we want. Now, since we are modeling cast in situ concrete, so we're not going to go for assembled. Assembled stair basically made in the fabric, in the factory, and brought back to the site. So you have different industrial assembled steel. We're not going to go for precast. There's also precast, we know it's made in the factory and brought to the field. We're going to go for cast in place stair, which is monolithic stair. So we're going to click on this one to be activated. Now the first thing you will do, starting from the levels, you start from the top of the foundation to the top of the first floor. But we said that not exactly the top of the foundation, 50 centimeters above the top of the foundation. This is very important to specify the exact location of the stair, starting from here till here. So this was the level, the top of the foundation. I gave 50 centimeter rise because we know that the stair, the first step will start from here. You go like this, and this is the top of the first floor. There it's exactly 0 because it will reach to this level. This is first thing you will do. Then we will go inside edit type. Still haven't drawn a lot of information. We'll go to into edit type. Inside the edit type you have a lot of information here. Now here the first part, let's duplicate first. Let me duplicate it. I'll just write stair. We only have one stair. I'm going to write stair. Now first duplicate it so that you will not edit the main component. Remember please, because if you have multi-stairs you have to duplicate, if not you will editing the other stair. It's very important, this duplicate is very important, because each component that you place in Revit, it's family. So if you edit the family, everything that you made out of this family automatically will change. So I duplicated, made a stair. Now this is, if you check, there is two. So stair, if I have another stair, I'll duplicate, I'll write stair 2, stair 3. Maybe you have multi-stairs in the building, they are different, so I prefer each of them to be different family. Now what we have to do, there are some rules here. Those rules, they call it maximum and minimum distances. They will give it to us so that when we provide some information here, by the way, we can do calculation in Revit. We can use Revit to find the number of risers, the height of it, the width of it. We can use Revit to calculate this one for us. So that's why we'll say that calculation rules here. Maximum height, riser height. For example, when you're designing this stair within Revit, Revit will not allow you to go beyond 18 centimeter. By the way, for the old people, it's preferable to be 15 centimeter. And if it goes to 20, it's unpleasant. So you will provide this one, maximum rise height. Minimum thread width. We say which one of thread? This is, so if this is the riser, so the height of riser. This is basically riser height. And this is where we step. This is minimum thread width. Sure, it's supposed to be bigger than our feet. Yes, if it's small, it cannot step. So here, minimum, for example, you say I need 20. It can be 25, 30. This is maximum 18. So it will not allow you to go above 18. It will tell you that you need more steps to make those are smaller. Now I need you to understand this one. The number of steps, we'll come back to it in a bit. It's related to the height of the riser, because if you going from one level to another level, you can make this one with how many steps? I can make it with 3 steps, yes, or I can make it with many more smaller steps. When you increase the steps, the height of riser will decrease. This is something easy to remember. But remember, if you increase the number of steps, you have this distance, so your stairs may be like this. You can do stairs like that. For example, if I go with, let's say I'm doing it like this, the stair will be, drawing. But the idea is what, if you have minimum width for thread, you cannot just, this will be the stair. Or you can do a stair like this. Yeah, in that case, what will you do? You will increase the risers. So, according to the place that you have it, you'll be able to do this process here. We're not going to go into detail of calculation, but the idea is you have to provide those information with the one that you have. And since we're modeling here, it's already been designed. So we're going to come back to the stair in the civil engineering. The details are here. So we have the thread, it's 25. You can see it here. Thread, we have 25. This is 16.6. Those are the actual values. So when I'm providing, I'll make sure that the maximum thread height will be 18. So 16 will be okay. Minimum is supposed to be less than this one, because Revit will not allow me, if I say minimum will be 30, Revit will not allow me to go with 25. So I'll make sure that minimum thread will be 20 for the rise. By the way, this is in a reverse way. If you're thinking that why I'm telling this one thread, this is, they did it in this manner. So it's a section. People are staying here. This is basically trying to go up like this. Now, what else I need to take from here? Now I got this one, 25 by 16. I need what? I need the run width. Look at here, 15. This is the part of run. I have the thickness of it. What else I need to take from here? The landing. This is place of the landing we have it, yes? What is the landing thickness? So if it is not here, for sure will be specified here. This is the landing. because people will come here, will stay here, and then go. So there is a thickness for the slab here, which is 15 centimeter. So the run and the landing, they have 15, 15. Now, do I have nose here? The nose, we said what? It's something like this. I don't have this nose here, yes? So I'll make sure that when we're doing it, there is no nose for the model. Now let's go back there. Well, maximum rise of height, let's say to be 18. I can make this one 20. Look, I'm not, when I say this is 20, I'm not making the stair riser 20 centimeter. No, this is the maximum. For example, this one minimum is 20. Minimum run width, it's 100. Again, minimum run, I can say this one 90. Those are just limitations. Now, we'll come here. Run type is written 25 millimeter nosing. Yes, you click inside here, then you click inside the, because this is part of the construction. We have run, we have landing, which we're supposed to choose. If we have support, we can add support. If not, we'll leave it for later. Well, I'm gonna go inside the run first. I haven't still specified the thread and riser, how many we have it. We'll go first into, like we came inside what? Inside the run. Well, here I will duplicate this one. I'll just say that the riser I have it 15 centimeter. Run I have it. Now, structural depth is 15 centimeter. Yes, the material is concrete cast in steel. You can change it. Now here, nosing base, they have it here. I'll make this one 0 because I don't have nose. Remember, the nose was what? Was we said that if it's straight, there is no nose, but sometimes you do it like this. So this is, we call it nose. This is nosing. You give this distance, how much is going to come out, which is basically will be here. No, we don't have, so I remove the nosing. I just have 15 centimeter, and the surface is smooth. This is something. The material is important to be cast in steel, or you can change this one as well if you want to make it same as the other material, or if you have a specific strength, you already specified them before. We're gonna show it to you as a short video how to create materials for the project that you have it. So you press OK. Now you have 15 centimeter run. This is first one. We'll go for the landing type. And you click on the 3 dots here. Come here. Again, I'll duplicate this one. I'll change this one to 15 centimeter. I have 15 centimeter landing. I have it here. By the way, the naming, we said that later might be useful. So 15 centimeter landing. I'll make sure I'll change this one to 15 centimeter. And the material, you have to be careful that it is the material that we want. So we'll press OK. Now we have some information here. For the support, I will leave it here. For the support, we'll leave it here. Now we'll press OK. Now I specified the information for the stair. Yes. Now we already specified where does it start. 50 centimeter from top of the foundation to the top of the first floor. Now we came to this part here to specify some dimensioning. So here we have dimensions. We'll specify some information there. What do we give here? The number of steps. How many steps do we have? An actual thread width. Like this is the actual one. And the number of steps. How do you know the number of steps? Well, from the architectural plan, we can see it there, that zoom here. We'll see number of steps. It's written 1, 2, 3, 4, 5, 6, 8, 9 till 18. You have 18 steps here, 18 riser that we have to provide it there. Now, if I provide 18 riser here, now what will happen? The actual riser height will be 16 point something. Like 16.66. Why? Because we know that, we already know from the design that it was 16.6 6, something like this. So when you provide 18 number of steps, it automatically will calculate, because we already told Revit it's starting from 50 centimeter top of the foundation till the top of the first floor. You calculate the height between them and divide by the number of stair steps, will get the riser height. Now we have to provide the actual thread, which we know for our case is 25, which is 25 here. Now I'm not getting any warning here. If you got any warning, it will tell you that the actual thread width is, for example, bigger than or smaller than the minimum. It will get some warning. The warning basically means that if you have any mistakes here, let's say that I provide this one to be 30. A mistake, oh, I didn't know that, this is 30. If I press apply here, okay, now look at, if I try to provide this one 20, yes, if I try to click out, it will change it to me. Now, trying to say 25 to get a warning. I notified the warning. So minimum thread depth. This is 30. So when we're drawing, we'll have a problem. And some of the version will give you. I had some warning. So there will be some warning coming up that the actual that you have it is less than the minimum. If you don't get it there while drawing it, you will get this notification. So I will make sure that when you're providing those, you'll understand that the maximum, the easy way to remember, the maximum rise of height to be bigger than the actual one you have it. The minimum depth of thread to be smaller than the one that you have it. Remember this one, will not make any mistake. For the run as well, to be smaller than, because it's minimum, so minimum was supposed to be smaller than the one that you have it. Maximum supposed to be bigger than the one that you have it. Now we didn't get any warning here, so I have all changed. This is 25, 16, 16. Now I have everything there. It's come back to what? Comes to draw. So we have to come and to draw the staircase. Now the run of the width, here it's written 100, yes. I can go back to the staircase to make sure that the run width, it is, so the run type, if I go back to the run type, to make sure that it is, there is nothing that related to width here. We already said that the minimum, it's 19 here. So I can go be above 90 to create the run. Well, now how much is the run width we have there? According to the architecture, it's 100, but the civil engineer, when designed it, changed it to 95. I will tell you what's the reason that they changed it to 95. We will focus on the civil drawing. Now this is, let's come over here, will be clear. Yes. Now this is the stair, we have it. As you can see from here, this is the run width. So this is the run width, which is 95. There is a gap between them, 20 centimeter. Then again we have 95 for the run width, we have it there. Now we have the landing. So the landing is this distance here. The distance we have it here. So look at the landing. The landing is from where we know that it basically finishes at the face of this column here, from the beam to the face of the column. So this beam is what? 25. So you have to take 25 from there. This is 25. Then this will be the landing here. This will be the landing. And we have two run. Now, Revit will allow us to modify the location of this stair. We can create it anywhere, then we can bring it to the exact location. That's what we're going to do. You don't need to worry about the exact location of it for the first time. No, if you got all the information, you will draw it, then you can bring it to the exact location. So, came to the drawing part. Now in the drawing part, you have something here. Run will be by the left, run will be by the right, to the center. You have different way to draw it. We'll tell you how to use them. Now let's say that run to the right. First we'll draw the run. Which type we have it? Straight we have it. I can use this one, yes, with the U-shape, winder, but this is kind of different than we have it. The run, it has steps inside it. We don't want this one. I mean, look at it, even the landing has the steps inside it. So this is something different. This one also, the landing, the L shape, one that has the same way. I mean, the steps are continuous. For us, we'll start with this one, a straight one. Now, we'll start somewhere, doesn't matter. We know that it's coming between those two, yes, but I don't know the exact location. We said it doesn't matter. I'm starting somewhere. I click somewhere. I said it doesn't matter. Anyway, we said yes, I'll click. Like if I go, it will draw the stair to the left. Why? Because the location line, it's on the right. Look, this is the location line, yes? We put the line on where? On the right of the run. So basically we're drawing by the right. It doesn't matter because we say we can move it when we need it, yes? But just an idea. If I can just simply change it to what? To left, you see that? This time I'm drawing by the left or by the center. So I'm drawing by the center line, Doesn't matter, any of them that you go. Now, the idea is what? How many stairs you have to go? We know it from the drawings, up to here was 9. So how do you know how many stairs I have drawn? Now, if you check the bottom tier, written out 8 riser created, 10 remaining. We had 18, yes, 18. We'll divide 9 as it was in the plan. So I will continue, move away, till we'll see 9. Example, this is writing 19 riser created, 9 remain. Sorry, 9 riser created, 9 remaining. I will click. So I will, when you reach to this point, you'll click. What will happen? It will provide this stair for you. Like this is 100, yes? I can change this one, just one click on it, 95. Hit enter, you'll have 95. Or in the beginning, I could simply provide 90, 95. I'm still on the run, creating the run, yes? So I'll change this one to 95. Let's say from here I can change it. Now, where do I want to draw? I want to draw the second part. Let me just show it to you. I want to draw the second part to be somewhere here. Yes, this is the second part of the stair, which we know starting from here goes like this. Now, from this point, I can take 20 centimeter, find this point of starting, and we will draw this line and we'll put the stair to this side and we'll get the second part of the run. If you do this way, Revit automatically will connect those two with a landing. We'll connect them with a landing. Then we can edit the landing dimension. So, in order to do this one, I will hover the mouse over this point. I will just move to this dimension. When you move, Revit will give you dimension. Yes, we already know this one. So if you move to this, Revit will give you dimension. Look, if I type 20, it will take 20 centimeter from that point and will click. But the way I'm drawing it will come inside down, yes? I'll just change this one to the left. So what will happen? We'll draw the staircase to the left. Now you cannot draw more than it's required. You cannot draw more than it's required. Even if you click here, look, that's it, because it will say 9 riser created, 0 remaining. Because in the beginning we told Revit that we have 18. So actual number 9 remains. Yes? So click somewhere when the riser, the drawing finished. Now you realize that Revit will connect them together with the landing. So this stair consists of 3 parts. Landing, a run here, and another run here. So 2 run, 1 landing we have it. So when you click on any of them, look at it, the information will come here. Stair run. Stair run. And you click on this one, will be stair landing, which is 15 centimeter. Now the dimension of this landing here, the dimension of the landing. By the way, this line in the middle, this is an indication for what? How the stair starts. Look, this line is how you use the stair. Well, let's manage the dimension of the landing to see if it is Okay, the landing dimension. Now it is 95 from here. Which one is supposed to be adjust here? We already know that this is okay here, yes? This dimension is okay. There's no problem with this one, because sure it's going to start from the side of this run to the side of the other run. And we already know this distance is 20. It's 20. The only one that we have to adjust it is this part here. Well, we have to go back to the actual drawing to see how much is exactly this landing here. Now the landing, we said that it will be up to here, yes? Now if I cannot see it from here, I'll just simply go to, see if it's provided here. Also we haven't provided here. We'll go just to the architectural drawings in order to get this landing. Now the landing here, it says 100. Look at here. The landing, it's this part of the landing here. We have it here. If you can see it, it's starting from this to this part here. Now, problem is this is 20. Yes? This is 20, we have it, the wall. So, according to the staircase, we have it there. Let's just go back to the staircase to explain this one as well. This is from the wall, yes, but according to what the structural engineer designed, the staircase has a support, the beam support, which we'll come back to it. So if you see it from here, there is this beam support, yes, there is this beam support. So the landing that we have it, we can bring it till where? Remember, till here. I can stop it till here, and then we can add this beam to the stair. So in that case, if this is 25, this is 25. Before, if it was 20, would be 100. Now 5 centimeters will go, it will be 95. Or we can manage it in different ways. Well, we can calculate it from here. We already know this column, for example, the length of this column, we have it. We know this column, the length of it. I'll take this 25 to get this part here, which will be 95, because this is 120, this column, 120, we have it, so this will be 95. Well, according to what Revit automatically gave it, it's 5, no problem. Now we just have to adjust this one within the place that we have it, yes, adjust it. Now, in order to adjust this from here, it's basically, I can just bring this corner to somewhere here. I just need to bring the corner to this point here, which is 25 centimeters away from this. So I can bring it here, then I can move 25 to this point. Well, I have this one. So you can click on the run. When you move the landing, the run will move with it. Well, I can click on the move, take this point here. Look, where is exactly that 25? I don't know, yes? I can bring it first to this point. It's not the actual location, yes? But now I can move it with it. Distance. I can use this one and move. Look, I'm moving vertically downward. Just to show it to you. I'll move vertically downward and I'll type 25 centimeters from there. So it will directly move from this corner 25 centimeters and it will come exactly to its location. Because when we add a beam here, when we add a beam to this landing, you will realize that the 25 will fit to this place. Now, you press finish button and you have the staircase. Now you will get a warning. It says that the railing not continuous, break in the rail. The rail basically, it's the, I'm not going to go into detail of them, it's around the staircase, and you will not see the staircase even in the drawings. Now we'll go back to, we're on the top of the foundation. Is if I go to 3D, now in your case you might not see the staircase. You might not see the staircase there. Now if you don't see it, what will you do? nothing is active, the mouse is within the screen, you will type VV. Twice you press V. 2V. This is visibility override. So I'm cancelling. Look, twice you press V after each other, you'll get this box. They call it visibility. Now in the visibility, if in the beginning, if you remember, I told you that when we open the structural template, a lot of things will be hidden. A lot of things will be hidden. Some things, we have a lot of parts, yes? So you have a lot of elements in Revit, but not all of them are shown in a structural template. Look at them. For example, furniture is not shown in a structural template. So the one that ticked means that they are shown. Some of them are not shown. By default, this is what we call the template. Well, now I need to show staircase, yes? Well, what I'll do, I'll just activate structure, not the other, I don't care about the others. I'll just make sure it's structural, it's active. Now, staircase by default is like this. You can just click on it, you can see staircase. If you want to see any other things, look, this is column, but this is architectural columns. Or ramp, if you have ramp, you'll click on the ramp, you'll see it as well. Look, those are the structural, but all of them active. Some of the others are not active. Roof, if you want them, you can activate them, deactivate them. This is, we call it visual graphic overrides or visibility overrides. Now remember, in Revit, each view, they have their own visibility overrides. This is what? This is for 3D view. So if you go to any of these plans, they have different things. Remember, in the elevation, you have different things. Even their scale, everything here in Revit are separated. In order to give flexibility in the drawings, they have these options. Well, make sure stair is activated. Then if I press OK, I'll see the stair here, yes. Now I removed the opening because I wanted to show you something easier, how we can manage. By the way, how do you rotate? You press shift and wheel in the mouse, the middle button of the mouse. This is the stair, I have it there. The landing, this is the part we have it, the stairs goes there. Now, why did I remove the opening? I told you some people, they prefer to create opening after they create the stair. I'm gonna show you something in the next video. It's better to create it. Now this is creating staircase. Remember, there are a lot of details you have there, a lot of details. You have to be careful when you're creating this type of staircase. In the next video, we explain how to open a shaft, an opening, when we have the stair, to see how easily we can locate the location of the opening. Thanks for watching.